Welcome everyone to our presentation today on building with satellite connectivity using the Blues Starnote and services from Skylo Technologies. We are super excited about this product. I think you will be as well if you're not already. Now, the whole Final Frontier thing is an obvious call out to Star Trek, of course, but I think it works, at least for me. The fact that we as consumers can sit here and program a device that literally communicates with satellites in space. Well, it's kind of something of a wonder, right? I guess we just need those replicators and what are they called? Transporters from Star Trek, and we're all set, right? But for Blues, really, satellite connectivity really adds to what we at Blues are all about, and that is this topic of wireless harmonization. This is the idea that product builders should really be able to build future-proof solutions by choosing the right radio access technology without making those upfront commitments, right? Without painting yourselves into a corner. So use cellular, use Wi-Fi, use LoRa, add on satellite, use them all. I don't care. Just do what you need to do to get your product to work. Because in this magical harmonized world, when you choose the right radio for your product, that should be really a deployment time decision instead of a development one. So you should be able to develop a product prototype, and then when it comes time to deploy, then make the choice of cellular, Wi-Fi, LoRa, again, add on satellite, all based on the specific needs of the actual physical destination that you are deploying to, not based on what you previously coded in firmware. Now, case in point, we were just at Automate Chicago a few weeks ago. We're partnering with Arduino on their launch of the Opta Mini PLC. So Blues is the cellular and LoRa connectivity provider for the Opta through our new Wireless for Arduino Opta expansion kit. Arduino has been a fantastic partner for us and is really helping us to prove out this idea of letting people just be able to use whatever connectivity option they want to use. And yes, this is very much a shameless plug, but I assure you this is a pretty cool product from Arduino and a great option if you need to add on cellular to it. But this is all really important because at Blues, really everything that we build is not only radio agnostic, but it's also host agnostic. We let you use any modern MCU, any modern single board computer. We let you bring your own language, your own RTOS. If you want to start prototyping with Arduino and deploy with Zephyr, that's totally cool with us. We're also cloud agnostic. We want to help you get your data from your device to your cloud. We don't care if that's an AWS or Azure or Google Cloud or an IoT platform like a Data Cake. Anything is fine with us. But today we're obviously focusing on said satellite product from Blues, that being the upcoming $49 Blues Starnote. So it will be available for sale next week on June 3rd and comes in the two variants you see here. Today we're going to be diving into all the details about the product and specifically how to use Starnote today. But before we really kick things off, if you have any questions, be sure to ask those in either the Q&A panel or the chat panel provided. Either is totally fine. We do want this to be a little bit more of a casual conversation, so feel free to ask those questions as they pop into your head. We'll answer them as they come up and then hopefully save some time for the end to answer some more public questions. Now, a question we always get is this being recorded? Will it be available later? And the answer is always yes, it is being recorded. It will be available on the Blues YouTube channel at this URL. While you're there, I recommend subscribing, of course, to the channel as well, so you're the first to see all of our video content. So let's do some quick speaker intros. My name is Rob Lauer. I'm Senior Director of Developer Relations here at Blues, but far more importantly, I'm happy to introduce Satendra Yadav from Skylo Technologies. Skylo is our connectivity partner for Starnote. We also have TJ Van Tol, who's our principal developer advocate here at Blues, and TJ will be doing the technical demo of Starnote. We also have Hugh Stevenson on the line. I forgot to include Hugh in the slide here. He was also from Skylo, so thanks for joining, Hugh. Now, hopefully you caught this in one of our invites to the webinar, but we're actually giving away 3 Starnotes after our presentation today. There are 2 requirements, though. One is that you actually attend the webinar, so that's an easy checkbox for everybody here right now. But you also have to provide us with a shipping address in a supported region of Starnote. Now, I'm going to put a pin in on that. We're going to come back to coverage a little bit later. Now, I do want to take a moment to address those of you who are new to Blues and how we approach wireless connectivity in the IoT, because it's a little bit different than other companies. And I want to start with the core hardware product that we provide, and that is called the Note Card. This one that you see here is a dual cellular and Wi-Fi IoT device. The cellular side comes prepaid with 500 megabytes of data and 10 years of cell service. That's all baked into the cost of the device. At Blues, we are not about monthly SIM or monthly data fees or monthly minimums, nothing like that. But really, the hardware that we provide is only half the story. The other half of the value we provide comes through with our cloud service that we call NoteHub. Now, the two products work together to form what we call a device to cloud data pump. In practice, what this means for you as a developer, you're going to buy a starter kit from us, hook up one or more sensors to it, then start reading data with the host microcontroller, and then deliver that data securely to NoteHub. But most importantly, NoteHub is then going to route that data to your cloud. So yes, NoteHub is a cloud service, but we are really not trying to create a platform that locks you in. We exist to help you connect to your platform. Again, that could be a big cloud, it could be DataCake, UbiDots, any of those great IoT platforms as well. Now, there are a lot of note card options available, but the cool thing is they are all swappable in terms of both the physical connector and the developer APIs that we provide. There is a line of cellular-only note cards. There are low-cost Wi-Fi only note cards. There are also low-cost LoRa only note cards, and a set of dual cellular and Wi-Fi note cards that let you fall back from Wi-Fi to cell. Speaking of fallback, we then get to Starnote, our topic of the day, which is a satellite add-on for the note card that allows for fallback from cellular or Wi-Fi to satellite. Now, just looking at the note card in a little more detail before we continue, it is a low power system on module. It has that M.2 connector at the bottom for embedding in a project. As mentioned, 500 megs of data, 10 years of service baked into the cost of the device. The cellular note card does have an onboard embedded SIM, but also provides dual SIM support if you need it. The API, this is going to be interesting for today. The API, the way you interact with the note card is all JSON-based, and you'll see this play out in TJ's demonstration as well. But we also have SDKs available for popular languages and RTOSes. And lastly, we provide note carriers. Now, these are carrier boards. They're development boards that let you hook up a note card to virtually any product you can dream up. And this one in particular that you see is great for working with a Feather-compatible host, but there's a lot of others. And I do want to be clear that when you invest in Blues, you're not just investing in the note card. Blues really does provide this end-to-end, and in the case of cellular, literally off the public internet communication channel from the note card through to our cloud service NoteHub onto your cloud of choice. If you want, you can even optionally encrypt data from beginning to end. And again, you can deploy with cellular, with Wi-Fi, LoRa, hopefully add on satellite as well, and not jump through a lot of hoops to get there. It's really a very simple but very powerful and secure workflow. So with that out of the way, let's dive into Starnote here. So starting with, let's look a little more closely at the hardware itself. First and foremost, Starnote is a note card accessory. This means it must be used alongside an existing cellular or Wi-Fi note card. It doesn't run on its own, at least not yet. That's because the design center around the note card is as a fallback or failover communication device. So you start with cellular, for instance, and then fall back on satellite if you lose connectivity. You can, in theory, use it as a primary radio, but it does still need a paired note card as of today, and then you're going to have to consider the costs of using it as a primary radio as well. It's important to know that you don't program Starnote directly, and you'll see this play out with TJ again. Since it does work with a paired note card, you program the note card, and the note card then decides when and how to use satellite connectivity based on your requirements. Now, thanks to our partner Skylo, Starnote accesses geostationary satellites. So you're not waiting for a satellite to move into view, for instance. And you actually use the same cellular LTE antennas that you've been using to communicate, which to me is a bit mind-blowing. And it does ship prepaid with 18 kilobytes of data, and this probably doesn't seem like much. And it's not, but it is enough to send one 50-byte payload per day for about a year. You can pay to go beyond 18 kilobytes of data at a rate of 75 cents per kilobyte. And to put that into some kind of perspective in terms of the pricing, those of you familiar with Blues know that part of the reason we got into the cellular business was because of the insane pricing models. And I would say that satellite is no different, if not much worse. So today with satellite, you either get nicked on monthly device minimums or high rates per kilobyte. But I'd say a really important feature of Starnote and Blues is that we're not enforcing monthly minimums, and we bundle in that first 18 kilobytes of data to get you started with a pretty reasonable rate beyond those 18K. And as mentioned, there's two Starnote variants. They only differ in their antennas and the length of them. So the one on the left uses onboard antennas provided by Ignion. And we also have one on the right with the UFL connectors for attaching your own external antennas. Now, at a very high level, this kind of lays out the outbound and inbound paths of data from the note card to Starnote to the geostationary satellites via the Skylo network to NodeHub, and then onto your cloud endpoint. And frankly, as complicated as this might even look, truth be told, you only need to care about what I'm highlighting here. Blues and Skylo eliminate all this complexity of satellite connectivity so you can focus on your product design, leaving the hard stuff for us to handle, frankly. So that's really Starnote at a glance. Next, I wanted to touch on how to actually get started incorporating satellite connectivity. And starting with the hardware itself. So let me first introduce you to the Note Carrier XS. This is a new specially designed note carrier for use with Starnote. It does feature both quick and eSLAV connectors for attaching peripherals. It does, of course, work with either Starnote variant. The one pictured here is the one with the UFL external antennas. We're also starting to replace micro USB with USB-C on our note carriers, which some of you will be very happy with. So it's really a very simple setup. You just slot your note carrier in, you slot your Starnote in on the left, and then you slot your cellular Wi-Fi or Cell plus Wi-Fi note card in, and you're good to go from a hardware perspective. Now, when writing firmware to work with the Starnote, again, I repeated this a lot, but Starnote only works with a paired note card. So you're programming the note card to decide when and how to use Starnote. And that starts with something called NTN mode, which stands for non-terrestrial networking. Now, NTN is the 3GPP standard for satellite-based interaction with cellular networks as provided by Skylo. And when communicating with the Skylo network, Starnote uses non-IP data delivery. It's something new to me, but it is a message-based transmission protocol where all the data that's transmitted contains only app-related information, and the transmission only lasts as long as it takes to send data. So it's extremely efficient. I read somewhere that compared to like IP-based messaging, which probably most of us are more used to, it's like the difference between sending a text message and a phone call. And specifically, you can tell the note card via the card.transport API to only communicate in NTN mode, or more likely tell it to start with Wi-Fi and then fall back on NTN, or start with cell and fall back NTN, or the Wi-Fi to cell to NTN path as well. So you have options there in determining which types of radios to use before you hit satellite. Now, when working with Starnote, we do require that you use templated note files, and this is to save on data in transit, so save on bandwidth. If you're new to Blues, new to templates, really they're just effectively hints for the note card that allow it to store and send data far more efficiently as packed binary objects. And with Starnote as well, there's a new compact format option that minimizes data even further by reducing some additional metadata that gets sent over the wire. And all communications, so meaning outbound data from the note card, inbound data from the cloud, and environment variables from the cloud, they must all be templated as well. And I know this is a lot of information to send you, but all of this is fully documented at dev.blues.com as well. And oh yeah, last, this is an example of a properly formatted note template definition that uses that format compact argument. So that's it. Really, with just the card.transport and the note.template APIs, you're pretty much ready to use Starnote. And again, TJ will show this all off in a bit. Okay, now coverage is a big deal for obvious reasons. And today, I admittedly do not have the latest coverage map from Skylo here, but today, Skylo provides support for the US, Canada, most of Europe, Australia, and New Zealand, along with their nearshore areas. However, coming soon, they're going to be opening up many other regions, including Brazil, Japan, Taiwan, much of Southeast Asia as well. And to get back to the Starnote giveaway, these are the regions we're talking about. So If I reach out to you and you're one of the winners, I just need a shipping address from you in any of the green or yellow highlighted areas to be eligible for the Starnote giveaway. Now, I've obviously mentioned Skylo a few times already. To be clear, Skylo is a non-terrestrial network service provider. They're the ones providing this exceptional satellite to cellular option to Blues. Skylo's technology is built on top of the latest cellular industry standards. So you don't need new modems, you don't need new antennas. That makes satellite connectivity so much more affordable and so much easier to integrate. And frankly, I can't really do Skylo justice with that intro, of course. So to that end, I'd like to invite Satender to the stage from Skylo. Satender is Skylo's Director of Sales Engineering and, of course, can speak far more intelligently about satellite technology, the satellite technologies in use by Starnote. So I will stop my share here and let
Thanks.
Satender take over.
Let me see if I have. Okay. So is my screen visible?
Looks good.
Yes.
Yep. Perfect. Thanks, Rob. I think you're given enough introduction of Skylo anyway. I'm just going to take a bit of step back in terms of giving you a background of what Skylo is and why are we doing this, right? So if you look at the world we live in, right? The world is changing every day, right? And the demand for continuous connectivity is every day increasing. Like if you look at the deployments on IoT on a consumer side, people wants to be connected all the time, right? And the existing technologies what we have today is cellular or private area networks. They don't cover the entire globe, right? The traditional satellites what we already have, they don't play well with cellular networks, so there's no interoperability. And obviously, there's a dedicated proprietary hardware required for the traditional satellite network if you want to connect to it, right? But there's an advancement of technology already happening every day in the world we live in, and that has given a lot of precedence to satellite IoT network, where the convergence of cellular and satellite make it a global connectivity for everyone, right? And the change of technology has bring in multiple aspects. One is standardization of satellite communication technologies, what is happening in the world today. We are looking at multi-orbits and multi-technology solutions coming in for a single devices, what we look at Blue Starnote also. And we are looking at satellite integrations to be done with standardized 5G networks to be done, right? And on that note, let me just give you a brief intro of what Skylo is all about. Like Skylo is basically, we play two roles. One is obviously a satellite network operator, and the second is technology orchestrator, right? We are part of a ITU. We are a member of GSMA. We run our own core networks. We have our own RAN entire network, and then obviously the core network is in cloud right now. We do have our own PLM and ID, so it means that we have SIM preparers all over the world. We have partners with them, and we can provide SIM cards. We do serve two different use cases. One is the IoT and the consumer. Consumer means we are looking at two-way messaging, SOS solutions, and when it's IoT, it's all about deploying and connecting those devices which are mission critical, remote places, and other stuff, right? But the advantage is what we bring is you can connect your same device which connects to cellular today, and you can deploy to those remote locations where there's no cellular. You can connect the same device, same antenna to satellite as well, with the same SIM card, same relationship, whatever you have it, right? If you look at how the business model works is we work with MVNO/MNO partners and also like service providers like the way Blues is. And we are licensed over more than 30 countries. And we are aiming to have a global coverage, but today we cover almost 4 continents, which is North America, Europe, Australia, Japan, and everything right now. I wanted to give a glimpse of how the ecosystem looks like of the Skylo. If you look at the chipset and the module makers, we are close to almost every leading module partners and chipset partners who are working with Skylo to standardize this service and bring this service to the market. Look at the chipset partners like Qualcomm, you're talking about MediaTek, you're talking about all the others, and everyone is online, right? We do have third-party labs and everyone which can basically certify the devices on a network. There are multiple partners who have launched devices, consumer and IoT on a network already, and there are MNOs and press releases who have already publicly admitted that they have integrated our network with their network, like just a roaming network for them. Just a standard way of putting it that you can connect any device anywhere with Skylo NTN network, right? And it's just not about, as I mentioned, it's not about just two-way messaging. It's all about location data, any kind of payloads coming up from IoT/consumer devices. One of the best thing what we do is we don't need to have a spectrum or carrier spectrum needed for Skylo to provide that services in a specific geography. We just need an operator license, and that makes it very, very scalable to the market. We basically can open a market in a much faster time than what traditional satellite player has been doing that. We do cover the entire world because we are talking about geostationary satellite, which 4 satellites should cover the entire world. It's just a function of market demand. The moment we have demand from a specific geography, we will open and prioritize that geography for everyone. But since we looking at global coverage, we will end up doing global coverage most probably by end of next year, sooner or later. But prioritizing a geography is something which is very, very important based on the demand that we have. As Rob mentioned, you don't need to have an extra hardware. Existing hardware can connect to satellite. You don't need to have a gateway and other stuff. And with this, I think we're looking at 2.53 billion devices on this right now. And as mentioned, like we're looking at use cases. We are talking about smartphone. We already mentioned smartphone and wearables. We're talking about messaging, SOS. Automotive is one of the biggest use cases which we think is going to be needed for NTN. And IoT obviously is one of the major ones. The moment you want to take a deep dive in terms of IoT, we are looking at use cases of remote agriculture, pipeline monitoring, automotive, maritime, energy. I know there are a lot of them. I might be not known to all the use cases. The one use case I think which we got recently used to it is cattle tracking, which I'd never heard of it, and one of the biggest use case for NTN. But yes, there are multiple use cases, and I'm amazed to see when customers bring up use cases which are not even heard of, and you see that $1 billion industry is already building up on those use cases, and which we can be served without any extra hardware and basically connecting those devices and to the NTN network. Just a basic glimpse of how this network works, right? As Rob mentioned, it's a packet-based data. It's not non-streaming data. It's a NB IoT data, very standard-based 3GPP R17 based. We work in MSS, which is mobile spectrum services, and the 3 bands which we work on is band 255, 256, and band 223. We do support non-IP and UDP. As Rob mentioned, that the advantages of non-IP over IP is huge in terms of saving a lot on header. But since it's a very, very small bandwidth we're talking about, we do support UDP also for now. The maximum size of data packet we're looking at 256 bytes, but a packet would be around 50 bytes on a single time, but maximum MTU would be 256 bytes we're looking at. The average latency we're looking at 10 seconds. I do see some questions coming up, so I hope all these questions would be answered. If not, then I will basically look at those questions and answer those in a Q&A session. We do support power saving modes. PSM and ADRS are already supported, and we can share the tables in terms of what timers we have already allowed on the network. Basic step, like if you want to connect a device with Skylo NTN network, it should be certified with us, like the first thing. And a type 1 and type 2 is basically nothing else. It's just the TIS and TRP requirements of a device, which means that RF performance characteristics. It should have a GNSS capability to close the link with the geostationary satellite what we have. And as Rob mentioned, it needs a standard LTE antenna. We're not talking about any custom-based antenna. And obviously, you need to have an NTN-capable SIM card, which Blues can anyway deliver that. And we are looking at devices must have an ideal line of sight, right? We would expect to have clear line of sight, but ideal line of sight can continuously work on Skylo network. One of the major things, as I mentioned about, is device should be certified on a network. And the three things, like if you look at the certification level, basically works on three things, right? One is obviously like any device or any network provider, we need to have a bare minimum level of device performance on a network. And the three level of certification works on, one is the chipsets, module, and the end device. Chipset needs a lot of work because it needs the implementation of NTN protocols on the chipset. This means that once a chipset is certified on a Skylo network and a device or a module is basically built on, then we're looking at RF performance characteristics and front end on the module side. That takes around 2 to 4 weeks on that. And then if a device wants to certify who's using a certified module, using a certified chipset, then we're talking about just a spot checks on a network, which is done using an internal team here at Skylo. But we have also enabled third-party labs, which you can go and certify your end devices, done all kind of Skylo test cases, and submit those report back to us, and we will certify your device for you. Right. As Rom mentioned, this is our latest service coverage we have, and I guess we have added Japan now for this one. But as I mentioned, one of the important thing is technically we cover almost the world. It's just a matter of fact that once we have demand coming from a certain geography, we will prioritize that, get the regulatory approval, and then we are good to go on the particular geography. As I said, spectrum and anything is not a challenge for us because we use or leverage one of the existing satellite partners on a satellite. We don't own satellite assets. So along with that agreement, we also leverage the spectrum, and that's why we can reach or scale the market very quickly than what existing partners have been doing that. One of the things which I wanted to just show is like this is one of the off-the-shelf device which was available with us with an internal GNSS and internal antenna. Look at the smallest device. This is like on the palm of a hand, and we could connect this device on a network, put it on a dashboard on a car, and drove around Mountain View to Monterey. We never missed a data. I don't know how many of you are familiar with the route takes from Mountain View to Monterey, but we're talking about red giant woods where you don't see the proper sky, but we never missed any kind of data here, and the device was able to send data continuously, right? And on that note, I think I'll hand over to TJ. Back to you. Thank you, everyone.
Yeah, so I'm going to take it from here because I mean, I want to send some data to space, and I'm sure you all want to see how this all works. And to do that, I'm going to start by just switching over my camera for a second, just to show you what the hardware looks like, because I think it's one thing to see it in slides, and it's another thing to just see it in person. So what I have are these two Starnotes. The whiteboards are both Starnote. This one is the one with the onboard Ignion antenna. And then this other guy up here is the version of the Starnote that uses the external antennas. And I'm very specifically using the external antennas for this demo because, as Satinder mentioned, you need to have clear or ideal line of sight. And I can tell you very much that my office does not have ideal line of sight to the sky. So for this demo, I am routing an antenna connected to this UFL connector and out my window in a way that my wife is not particularly happy with, out to an antenna that is mounted on my deck that has a very nice line of sight outside. So hopefully it means we should have good luck with our demo today. Now this board from Rob's slides you might remember is called the Note Carrier XS. It's designed so that you can slot in both a Starnote and a note card. This one happens to be a Cell Plus Wi-Fi note card that I'm going to be using as part of this demo today. And then you'll see some of the connectors Rob mentioned also for things like quick connectors, eSlav. There's a JST connector if you wanted to hook up a battery to this. And then the USB-C connector is over here, which is what I'm going to use to connect this thing to my laptop here momentarily. I should note that what you see here, the Note Carrier XS, these two Starnotes, and then a note card Wi-Fi, so a slightly different note card, is what we are going to be offering in a Starnote dev kit. It will be in our shop, I believe, next week. So I'm mostly using the hardware that you would use from a dev kit from our shop, other than I'll be using a Cell Plus Wi-Fi note card instead of a note card Wi-Fi. So this one, what I'm going to do is I'm going to take a second to move some screens around, and I'm going to share my computer screen. There this desktop here, move zoom out of the way. And then I'm going to take my hardware, making sure I don't knock anything down with these wires. So I've got a USB-C cord, and I'm going to plug in my Note Carrier XS into my computer and talk about how we're actually going to configure and use this thing. So the first thing I want to show is I have up dev.blues.com, which is our thing, our site for all things development at Blues. It's where you'll find all our tutorials, our guides, our data sheets, and whatnot. And the place to start when you have hardware, or even before, actually, is the Starnote Quick Start. You can find this in the Quick Start section of the docs, or honestly, if you just search for Starnote, this is going to be the first thing that comes up. Everything I'm going to be showing off today is covered in one way, shape, or form through this Quick Start. So I'll be giving you kind of a quick tour of this, but if you want to go through this, you can actually go through a decent chunk of this on your own and just learn about the new modes of the note card and how they work and try them out. And then if you do come back to this with physical hardware, it'll also walk you through how to set that up and get running today. So this is a good one to just come back to later on if you're looking for more detail of what I'm talking about, or if you want to try any of this out for yourself. All right, I'll be using two tools to give this demo. Both of these are going to be familiar if you're a longtime Blues person, but just quickly for people that are new, I'm going to be using the in-browser terminal that we offer for the note card. So you can communicate with the note card over serial, and we offer CLI tools to help you do that. We have firmware libraries to help you do that. But we also offer this really convenient browser-based tool that we use for a lot of our demos and for our tutorials. The Quick Start will show you how to use this as well. So I can connect to my note card just straight up in the browser and start sending it requests, which I will do here in a second. The second tool I have open is NoteHub. So this is our cloud backend service. One of the cool things about the note card is that all note cards know how to talk to NoteHub out of the box. You don't have to do any cert management, any provisioning, anything like that. The note card just knows how to communicate with it. The one thing you do have to set up is a project, which is what we're looking at here. I created a project, just got it ready to go, just set up so that we can do this demo here today. And all right, so let's set up the note card. What I'm going to need to do is paste in two different requests. And I'll talk about what each of these are actually doing. So the first is the hub.set request. This is kind of your bread and butter standard request that you have to run on every note card project you do. The main thing the hub.set request tells the note card is which NoteHub project to use. You might notice this identifier matches this identifier here. This is basically linking your physical hardware with your cloud backend. And then the second thing I'm providing is a mode. There are several different modes built into the note card. I'm not going to go through each of them here today, but I will say minimum mode is really handy for satellite testing because this is a mode that tells the note card only synchronize with the network when an explicit hub.sync request gets run. It's a nice way to control exactly when network connections happen, which is really nice for demos, which is why I'm mostly using it. But it can also be handy for satellite usage where you are really want to be careful with the amount of data that you are using. All right. On that note, the second request I'm going to run, and this is the one, it's actually verbatim what Rob had in his slide earlier, because I'm also getting this from the Quick Start, is this note.template request. So this is a request that tells the note card exactly the format of the data that you want to send. And the Quick Start will walk through everything in detail. The two things I'm going to point out to you is the most important parts are the name of this. So basically the file name, which I'm calling sat.qo. So the name of this templated note file. And then this bit, the body is basically telling the note card the format of the data that we expect to send. What this template is essentially establishing is we're going to pretend we are an environment monitor type of project. We've got a temperature and humidity sensor hooked up. Maybe we're operating off the grid and we need to just send in temperature and humidity readings at some certain interval. These 14.1 identifiers represent a 4-byte floating point number. And again, if you go through the Quick Start, it'll give you an exhaustive list of all these things. But this is essentially saying entries to this file are going to have a temperature and humidity, and they're each going to be 4-byte floating point numbers. And that's going to tell the note card how to efficiently store that data and transmit it over the network. Because again, we're making every byte count as part of building these types of projects. All right, so at this point, I actually need to do one additional step here. I need to synchronize this data. And the reason for this is that not only does the note card need to know about this template, but our cloud backend needs to know about this template as well. Essentially, this is going to allow the note card to send this data in a super compressed way. And Note Hub has to know about the template as well, so that it knows how to receive this data, because otherwise it's just going to look like garbly-gook coming in. So it needs to know how to interpret this. Because this is a cell and Wi-Fi note card, and I don't have Wi-Fi configured, you see that's what this warning message is yelling me about. This synchronization actually happened over cellular. So fun side note, if the note card is brand new to you, I just totally sent data over cellular and I didn't have to configure anything SIM. So random shout out to the cellular note card for being kind of cool also, because that totally just happened in the background. But we're going to focus on satellite because this was essentially our setup. So we told the note card about the project we want to use in the cloud. We told it about the data. So we're just doing one simple thing. In a more complicated app, maybe you might want to have multiple templates. You might have some more interesting things going on. But at this point, we have all our setup and we are ready to actually start interacting with data. Now, to this point, my note card has been sending data over cellular. And that's because the card.transport request that's built into the note card basically determines what radio access technology the note card should use. So this one, because it's a cell plus Wi-Fi note card, is set to Wi-Fi-cell, which means it's going to try Wi-Fi. And in this case, since there's no Wi-Fi configured, it actually sent that data over cellular. Now, you might recall from Rob's slides is that there are several additional methods that you can now use now that Starnote is a thing in the Note Hub and basically the Note Card and Note Hub ecosystem. NTN is going to tell the note card to just use an NTN module. And that's what I want to do as part of this demo. There are also other methods. If this will be an exercise for your own at home, but if you want to test out with some of the fallback options like cell NTN, Wi-Fi NTN, you can try those. They are not the most demoable features because I don't have a great way to take out my local cellular infrastructure to test that out for us live. So I'm going to keep things simple. We're just going to send some data over NTN. The cool thing is that there's no wiring I need to do because what the note card is going to do when you switch it into NTN mode is it's going to look to see if an NTN module is available, which you can either wire up manually, or if you're using the Note Carrier XS, that's actually one of the main purposes of the board is that all that wiring is done for you. So the note card is just going to know it's there and know that it can use it. And at this point, we can just send some data. I'm going to do one last sort of trick because I know that the first thing that the note card is going to do when you try to send data over NTN, especially when you boot it from basically from scratch like I did, is it needs to establish its location. The satellite module needs to more or less know where to look for satellites. So it'll do a GPS lookup. And I'm going to short circuit that just for demo purposes because I know where I'm at and I know I can save a few seconds on maybe even a minute or two on this demo by telling the note card exactly where I'm at. But again, this is just an optional step. If you have a clear view of the sky, that'll go by pretty quickly anyways. All right. At this point, we just send data. So the way to do that on the note card, or the easiest way to do that is with the note.add request. So again, we're going to pretend we're an environmental monitor. We're out in the field somewhere. Our interval comes up. We take a temperature and humidity reading. We use the note.add request to queue this up on the note card. So we have to make sure we adhere to the template. So this file matches the file from our template. This body conforms to the format we put up here. If all that's good, note card's great, says we're all good to go. The data is now queued on the note card. The note card primarily acts as a queue, and this is regardless of radio access technology. You queue up data on the note card, and then you decide what interval you want to synchronize this to the network. It's going to work the same way with satellite, although now we are in NTN mode, so we're going to be sending data using that satellite connection. All right, before I run this and make the magic happen, I'm just going to turn on trace mode, which is a little convenience mode we have built into the terminal, into our CLI that just gives us enhanced logging, which is nice when you're doing something like sending data over this connection. And then the last thing I'm going to do that's going to trigger all of this is run a sync. So because we went in mode minimum, the note card is only going to sync data when it sees this explicit hub.sync request. And in this case, I'm saying out true. So the note card can communicate bidirectionally with the cloud, even over a satellite connection. So you can send data that's queued up locally to the cloud, but you can also queue up data in the cloud and send it down to the device. So if you needed for SOS reasons to pick up on some sort of message or variable, those are options that are totally available and possible, but I'm only showing data going from the device up to the cloud. So I'm going to set this out true flag, and we are just going to do this and see how it goes. So watching the log, the first thing the note card notices that it's switching from modem to NTN mode. So modem just means cellular modem. So it's switching over to NTN. So it's going to check that it has an NTN module available. And it has this lat and long. So this is that step I sort of short-circuited by providing it here. So it's not going to have to look that up right away. Sometimes it takes a second to find it. And then what it's going to do is use our antenna outside. It's going to fire that up and send it out. So hopefully, if all goes well, when I was trying this earlier, this took about a minute to run. If it ends up taking much longer than that, I have a video I can show of it coming up. And then what's going to happen is we will see our data show up in this events list. And so over here, you'll see some of the metadata that came as I was testing out earlier that was coming through over cellular. And then this is going to try to send it over satellite. And I'll give this a minute to try it. It's powering up right now. So
TJ, which antenna are you using right now? Do you happen to have that? Do you remember? Because somebody had a question about that. And how long is your cable that it's extending outside?
So the cable is maybe 10, 12 feet outside. And the cool thing is because it's a standard cellular antenna, it's just one I got off of Amazon. So I have a little like gazebo on my porch up there. So I screwed it in to the side of that. And then I have an extension cable hooked up to it. I'm realizing now I should probably take the time to write this up, because I will say that the first time I tried this, I had to just go out into the middle of my yard to test this. And while that worked, it was not the most convenient situation. And I think my neighbors were really a little confused as to what I was doing out with my laptop and a bunch of wires just out sitting in the middle of my yard trying this out.
I saw Tom had a really good question here. Does NoteHub and the application endpoint know what radio was used to transmit the data? The answer is yes, but I will admit today we don't do a very good job of displaying that in NoteHub, and it's something that the team is aware of and working on. So you'll be able to really easily tell which events were sent with which radio, and also obviously something that's equally as important is to know how much data you've consumed with Starnote. So that'll be part of the NoteHub UI in coming releases too.
Yeah, you'll see it'll show me in the trace log when this sends it up. But that was one of my first pieces of feedback for our cloud team, is we need better ways of visualizing that. So I know that's something that we're actively working on. And
it just saw another chat coming from Tom. So there's no keep alive, there's no heartbeat, because again, we're being like extremely conservative with data that we're sending. So we don't want to do anything automatic. Like each heartbeat, if you will, would cost you about 50 bytes. That obviously adds up pretty quickly with Starnote. So we're putting the onus on the developer to configure the device the way they need it to work.
I'll give this one more minute, and then I'll just show this on video if this isn't going to come up. And then because really all that's going to happen is at the end you'll see an NTN uplink. And when I just showed it, probably what'll happen is I'll switch to the video, and then it'll just work, because that's usually how this works.
It's kind of purposefully not the most demoable product that we've ever released.
Yeah, well, and it's funny because in different times I've tested it, it's taken between like 1 and 5 minutes, something like that. But essentially, if I skip forward in this video, and I'll pause a second to let this buffer at this point. So you'll see some of the same NTN status messages. This is what you see as it's sort of testing out, trying to connect. And then once it does form that connection, you'll see NTN uplink and the data actually being sent up to the cloud, which just popped up there. That's where it's going to tell you how much data that things used. And then if you switch over into NoteHub and refresh, and it takes a minute just to finish processing on the cloud. So I wait like 10 seconds here and refresh again. You see the data pop up. And interestingly, you'll note that there's no location, because again, a lot of the usual metadata you might be used to on the note card by default does not get sent over satellite because we're, again, trying to minimize how much is being sent as much as possible. But that's basically the full workflow and just how easy it is to send the data through. Again, just showing that the body, the temperature and humidity made it through okay. And really, that's all there is to it. I mean, I think what struck me going through this process is kind of like I showed how Blues makes cellular simple and you don't have to worry about the nitty-gritty details. It's kind of the same thing when it goes to satellite. You don't worry about how the actual setup and connectivity actually happens. It just sort of magically happens for you. So then you get to focus. There's still some hard problems for you to think about, like how often am I gonna send my data? What am I gonna do with my data? How am I gonna structure all of this? But the part you're not worried about is how the heck am I going to talk to a satellite? That's the part you're basically abstracting away. And I think I don't know, I've enjoyed playing with it, and hopefully you're all excited to try this out as well.
Yeah, for sure.
That's my biz dev line is it works like magic and it's narrowband and it works like cellular roaming. So from the connectivity perspective, it's all taken care of for you.
Yep.
Awesome. So I want to get right to questions here. I just have I have one. Oops. I have one quick slide to show. Oh, my screen's not showing up here. And then we'll get to the Q&A. Here we go. So I just want to kind of summarize everything that we've been talking about here. So to be triply clear, the Starnote is a note card accessory, as you saw, designed for failover communications. TJ kind of circumvented that process, but I think you know what I mean. Again, does ship prepaid with for $49 with 18 kilobytes of data, and we can bill you later for additional data used. The two variants, we saw those today, one with onboard antennas and one with external antennas. Easiest way to get started is going to be by using the new Note Carrier XS. We are also going to have a separate Starnote developer kit available that I believe includes both Starnotes, a Note Carrier XS, and a Note Card Wi-Fi to kind of get you started as soon as possible. Coverage maps, the latest coverage maps will be available at skylo.tech. And of course, to repeat what I said earlier, all of our documentation and a set of pretty comprehensive best practices when using Starnote are available at dev.blues.com. So thanks so much for attending. Before we get to questions, just want to get these resources up here. As TJ mentioned, you can find our Starnote Quick Start, which you can actually use without a physical Starnote at dev.blues.com. Get your Starnote on Monday at shop.blues.com and skylo.tech for coverage map and more comprehensive technical resources. Now, I did see we had a ton of questions come in through both our Q&A panel and chat. Where to begin? Does anybody have a special question that they thought was exceptional that we should answer live?
I'll take. Yes, Tinder, you go first.
So I see a question was talking about Latin America in the roadmap, and I guess the answer is yes. We should be able to cover by end of this year. But Brazil is something which we are looking at right away. That end of August is something which we are planning to have Brazil. And as I mentioned, that global coverage should be by end of next year.
Yep, Adrian is in Mexico, so probably next year for Mexico, Brazil this year. That's a biz dev question. I can handle the biz
dev. Clark asked, did you just use 11 bytes out of your total? Yes, but there is a 50 byte minimum. So one thing that if you go to the bottom of the quick start, we have this section on Starnote best practices, which starts to get into the real world implications and how you might approach this. And one of our recommendations is that you keep your payloads under 50 bytes because there is that minimum enforced. So basically, yes.
There was a question earlier about latency. I know Satendra had a slide that showed about 10 seconds. TJ, what has your experience been like with latency?
It depends. There was somebody that asked a question earlier that I'm curious if these guys know the answer to. If things like weather affects transmission as well, because my big thing is that my data always gets through, but there's more variability than I'm used to. But I'm guessing that's sort of expected sort of thing, because I've seen everywhere from, maybe the fastest is like 10, 15 seconds, but I've seen it like in this case, I just saw my data went through in the background a minute or two ago, because of course it did, but up to like a few minutes on the top end of things. So it makes it, but it's like, yeah, there's variation.
It depends on the environment in which the device is being installed and how the antenna is. But in typical places, you're right, 10 to 20 seconds is what the latency looks like.
Okay.
Did everybody hear the demo worked, but in the background?
Yeah.
Classic demo gods. Thank you.
Yeah, exactly.
Well, Satendra, what about this last one? The total current consumed during transmission. The link budget is similar to cellular usage, correct?
Oh yeah, so if you're talking about current consumption, the power consumption on the device side, I guess we do have a case study on our Skylo website which talks about the power consumption of device on a cellular versus satellite. It's almost similar in terms of how much you consume, because you're looking at 23 dBm, the same power consumption on the NB-IoT on versus NTN. So there's no change on that perspective. It's almost same. I won't say this is exactly identical, but yeah, almost same.
There was you first.
I was going to say, would a better antenna have made a difference? It's not necessary. It's just same cellular antenna will get.
See, the better gain on the antennas is always better. But as I said, the minimum criteria is not to have the better antenna. It can connect with the standard LTE antenna, but if you have a custom base and a power on the antenna is great, it's always helps.
Somebody was asking about location. So if the easiest way to do location is there's a way to include as part of your template. There's some identifiers you can include as part of that. And then the note card will take the GPS location and send it along with each node. That tends to be ideal because just if you're using satellite, you have to have a clear view of the sky and you have to have a location. So you might as well just, if you need that position, you might as well just send the most accurate thing you got along with your data.
There's a question, I think this is a good question from Justin, which talks about how big is the constellation? Could latency be a result of waiting for a satellite for nearly overhead? No, this is the advantage of geo is like 4 satellites cover the entire world. You don't have to wait for satellites to cover or give you the coverage. It's always on. And as I said, our spot beams are nearly miles and miles. Like we are looking at 400, 500 kilometers of a one spot beam. So I think this is good enough for you to get you always on coverage. We don't have to wait for satellite to come and basically give you the coverage.
The latency is because there are 36,000 kilometers.
Correct.
Someone was asking, can Starnotes communicate with each other without hitting Note Hub? No. So the Starnotes and the Note card has to talk, and through the Starnote has to talk through Note Hub. This is a decent plug. Rob's working on a little demo project where he's building like a satellite messenger, so you might want to check that out here in a few days for Rob's write-up. Rob, do you have your...
I'll have it up somewhere soon. I've got the components here, but I've basically got a BlackBerry keyboard that has a host on the back here, and it's going to be connected to my Starnote setup. So I'll do outbound and inbound SMS using Blues and Skylo and Twilio. It's going to be awesome. So
we have a great job.
We're making narrowband cool again.
Exactly. I love it. There's a question earlier. I like this question about location, and if so, TJ demonstrated you could set a fixed location for your Starnote to not have to look up its GPS location first. And what's the tolerance in terms of how many meters it can move? And I don't know if Satendra, if you know exactly like what
I did answer that. I guess I answered that question, that few meters won't make a difference because it's a geostationary and the beam is quite large. But it's always better to see it's a geostationary satellite. You're talking about 36,000 kilometers away, right? So to close a link with the satellite, it's always good to have the as great location as we can have it, as close or as accurate. But few meters won't make a difference. I think we have seen that kind of connection working out. I see a comment from Tom about a question which is about firmware update. I didn't see that question. Teacher, did you saw that?
About firmware updates?
Where did it go?
So in general, firmware updates are not supported over satellite just for the straight up data constraint
I think that
reasons.
wasn't
Are
a,
you-
I think that was like a Starnote firmware update or a
Oh, I see.
like how is like satellite coverage updated?
Yeah. There's one question from Jan which talks about incoming messages supported. Yes, it's a two-way network for you. You can have uplink and downlink all in coming up. So we do support downlink messages also.
Yeah, and then on the note card side of things, basically you can define templates for inbound stuff as well. So on the note card, there's two ways of doing inbound data. You can either do them through notes, which work much like I did with notes handing up in one direction. You can also just do environment variables, which through satellite also have to be templated. But if you had like a setting that you wanted the ability to change over satellite, environment variables are the easiest way of doing that because you can just sync like maybe one integer or one Boolean over a satellite connection. And then you can configure intervals like check this in the context of satellite, maybe check this every day, every week, sync it down, and then make any changes that you need to make.
In the interest of time, I think we should probably wrap things up. And I know we did not get to 100% of the questions, but please feel free to reach out on our forum with any Starnote questions. Honestly, there's no stupid questions when it comes to anything that we're doing. So if you, I'll type the URL out here, but it's at discuss.blues.com. Feel free to reach out there. If TJ and I can't answer it, we'll find somebody who can. But yeah, so if we didn't get to your question, please hit us up there. And thanks to Tender, thanks Hugh for being part of this. I thought this was a great presentation, and thanks everyone for attending. And yeah, we'll see you
Yeah,
next
thanks
time.
everybody.
Thank
Thank
you
you.
so much.
Bye, everyone.